Let's see, in the previous session, they talked about this layer of intelligence that's needed, okay? And so and we consider that the missing link in autonomous operations. It's a missing link for getting your agents to work together, and it's a missing link for really going to level 4 autonomous operations. Okay? And so what I'd like to do today is a little bit talk about what that means, define it, tell you a little bit of how to build it, and show you some of the components that's required to build that. So in particular, okay, so first, we're all on this journey to autonomous operations, but on that journey, we know there's a lot of obstacles. Data fragmentation's been talked about, agentic AI accuracy, that was comments, especially at the end of the session. How do you make them accurate enough to trust what they're doing? And that trustworthiness has to be essential. So today I'm going to talk about 3 things. The first is knowledge. And by knowledge, we mean more than just the data itself. It's data plus semantics. We've heard that mentioned in the previous session as well. What's the relationships between all the data elements? What's the meaning of those relationships? Is that a dependency relationship, or is that some type of contains in relationship? All that's needed to be able to reason about what's going on in the network. Okay? And it's also the context, the setting in which it's in. The second thing that you need is what's called the semantic knowledge plane, and this is sort of equivalent to that layer that was referred to in the previous discussion. Yeah? And what that does is that gives you that layer of understanding. And we'll tell you a little bit more about what that means and how to build that. And then finally, we're talking about turning that layer into a continuously learning system. Okay? So you can keep all that knowledge up to date, you can extract all the knowledge from very different resources, keep it up to date, and be able to feed your agentic AI. Okay? So eventually, that empowers you to move to knowledge-driven agentic AI. So to do this, what I like to do is take a step back and say how we're using AI agents today. I'm going to do this in the context of a complex system. It's an AIOps system, because I chose that because it's real time, it's agent-based, okay, and it's critical to autonomous operations. Okay? So today we see that each of these agents are siloed. They have to go and retrieve their own data. That data may be fragmented. They have to figure out ways to repair, or guess how to repair that. They have to, each of them separately trained. Each of them, after the training, their learnings aren't shared. So if one learns something, it can't be shared with the other ones. And they're black box. They can't explain themselves. As Susan said, they're guessing a lot of times, but you don't know. How do you know when your agent's guessing? For this, we need a better approach. And that better approach is using knowledge, or knowledge graph, as some people refer to it. It can be in any format. It's a standard knowledge graph. It can be in the RDF format, et cetera. But it defines exactly what the data is, and that relationships, and all the context of that. So it pulls all of that together. Okay? And you can source this from multiplicity of sources, but the first one is simply to take the data you have, unify it, add that semantics to it, and that's your initial knowledge. By giving this knowledge that's shared by all of the agents, okay, you've integrated all the data fragments ahead of time, so they're not guessing and doing that. You're fusing information from fundamentally different domains in the network, whether it's a radio network or transport or in the data center, and fusing different types of knowledge. That cookbook knowledge that may be in someone's head, that if you can extract that and get that, you can then know what the key symptoms and fixes should be for this. It provides that semantics that you need to know that this is a containment relationship, so they depend on each other. If one fails, the other one will. It enables deterministic reasoning rather than probabilistic reasoning, because you follow the knowledge graph down. It's a basis for reasoning. And actually, there's many reasoning systems, not just Gen AI, which is more probabilistic. There's deterministic reasoning systems that you can apply as well. And you, of course, can have a mixed strategy for this. And it provides a richer context for all, because it actually has access to more information than the individual agents could retrieve through APIs. And that's very important. So the result of that is that now you have a system, though it looks like it's architected the same as below. You have anomaly detection, you have correlation. Correlation is very important, it's very hard to do. It's where you try to break, when you see these anomalies, you try to group them into groups that have a common root cause, and that's surprisingly hard to do. Right? And then you have the functions of analyzing those groups and determining the root cause, and then taking the right action, recommending a likely fix. So now, when they're doing this down the pipeline, they all are based on the same knowledge. And that's extremely important to that system. So how do you build this? A knowledge plane actually refers to a system that contains the tools for building and maintaining this knowledge. And these tools can come from a wide variety of sources, not just data, but institutional knowledge and other sources that you have. So for example, the first step is to take all that data and then to bring it into the knowledge plane. Again, as you do that, you fuse that data together because it will create relationships between data that comes from different domains, different systems. When they remain in those systems, that data is fragmented. You don't have those relationships. When you bring them into the knowledge plane, those relationships can be learned and manifest and documented there. You also add the semantics that you need, that understanding that you need, the difference between contains in, depends on, linked to, type of things. The second thing, so that would be your standard source of knowledge. It's in the data assets you already have. But there's more novel assets that you can mine to bring greater context. And that is, you can mine, for example, the telemetry data come in. Because not all of your data relationships, not all your network elements would be documented and linked in to your network inventory system or your CMDB. And especially the virtual components of that. Your virtual router may be running actually in a data center in a Kubernetes cluster. And Kubernetes, those clusters, the topology there is very, very dynamic. So the only way you can get that is to mine the input data as it comes in, and then you can recognize, you can deduce from that what those relationships are. It's got to be continuously mining because those relationships are continuously changing for that. So that's another source of knowledge that typically you don't have in systems. And you don't have AIs can't reason over because it's not there. But the other thing, which is actually, I think, more interesting, is you can go outside of those conventional sources of knowledge, and you can start looking at, for example, adding documentation, vendor documents about troubleshooting guides, for example. You can take an LLM to interpret that, to elementize that, and you can take that into the knowledge plane. Okay, you can also capture things, what we would call institutional knowledge, knowledge in people's heads, but are not yet in the system. Okay, and that is things like you can derive that from chats, especially chats of service reliability engineers. They're trying to solve problems, and actually what their solutions were to those problems. So you can mine that as well now. And then the other thing, which is very important, is to learn from your mistakes. So you can mine the ticket data. When a ticket is closed, typically the real cause of the problem and the real fix is in that ticket. The AIs may have predicted something a little bit different. So now you can learn the truth and mine that and put that into the knowledge graph and then refine their learnings. So this is, so essentially the knowledge plane is a system of agents out there that's doing continuously mining for you and building this knowledge. So let's see how this would work in practice. So let's take an example. Mobile users are experiencing problems, so the users are over to the left-hand side. We don't see the users, but the radio units up there that are red means that they have users that are experiencing problems. However, the radio units themselves are fine. They're healthy. No problem with them. And in fact, if you look upstream from that, the DUs, the cell site routers, etc., they're all green. It's only until you get up into the data center where you're running a virtualized router, a virtualized aggregation router. Now, why it's so hard to diagnose these type of problems, where, first of all, where the problem is and where the symptoms are far removed. It's across 3 different domains. The radio network, the transport network, as well as the infrastructure team or the data center team. So 3 different types of technologies, 3 different groups working on that. So these become problems that are very notoriously hard. But anyway, so now we have here the knowledge graph of that. And in that knowledge graph, you'll see all the connectivity between all those components. Now that was synthesized from at least 3 or 4 different databases or data systems, probably 3 or 4 different inventory systems. So here you're already seeing the assimilation of data into knowledge for this. Okay? And you can see things are laid out. You can see the health of each of the things here, each of the entities here. You can see in the transport network, everything looks green except that one element, which is the aggregation router. And then if you look closely over on the right-hand side, this is the data center topology. Now, this is a dynamic topology, so it's constantly changing. It's not going to be stored in any database or any inventory system. So everything there actually looks okay, too, except we notice one little red spot up there. And that means there's a container up there that is actually short on memory, and so that's causing some issues for that. Now, how all these things linked? They seem to be linked now. We see there's a possible linkage, but to really be certain, we can layer more knowledge into that. And that would be knowledge of the symptoms and the root causes, okay? And this is something that can be learned easily enough, and sometimes it's documented for that. So we add that to the knowledge graph, so we can very well see. We can see all of the routers, all of the customers on the same side having the same sort of problem. We can see that the aggregation router is having a multitude of problems, but one of them is congestion. And then we see that that container is having space problems and it is slow in forwarding messages. So now we can put the entire picture together. Now, this is a knowledge that we as humans would need. A lot of it would be in our heads, typically, if we were doing this manually. But this is exactly the knowledge the AI needs to do it correctly, deterministically, not probabilistically. Okay, so now you have a knowledge plane. You have it gathering all this knowledge together. And the next step is to really turn it into a continuous evolving system. And we already have the basis for that. If you look carefully into that, we already talked about how it can learn from its mistakes, how we can see trouble tickets coming back or whatever the records that the engineers provide come back, we mine those, and we can learn from those mistakes. And then we, on the front side, we actually are continuously mining data as well, so we can see changes in the status of things. And so what we see is this enables a virtuous cycle of learning, of learning more and improving, and so forth. So we have defined now continuous learning knowledge system. Okay. So to summarize, to recap, what we saw was, first, we talked about knowledge acquisition, disparate sources, that you can meld all this information together, very disparate sources, disparate formats. They all come together in the knowledge graph. Okay? We hinted at semantic modeling. I didn't show that explicitly up here, but that is taking it from just data relationships to understand what those relationships mean. Again, dependency relationships, for example, which are so important, marking those. Okay? Once we have that in place, now we can enable reasoning and inferencing, deterministic reasoning and inferencing, through a wide variety of vehicles. Knowledge-based reasoning, inference systems, etc. Okay? So we can bring that intelligence, that layer of intelligence with the knowledge and the reasoning capability to bear. That's available to the agents, of course. So the agents can now make context-aware decisions. They're not probabilistic, but based on the knowledge graph. They can explain themselves in the knowledge graph. And actually, that graph I showed before is a visual explanation of what's going on. Okay? So they can explain themselves, show you the knowledge graph they use for reasoning, and then that provides a way of providing guardrails and also allows you to validate what they did. A person can validate it, or another agent can validate it. In fact, in our systems we have a lot of judge agents, and their responsibility is simply to validate what another agent is projecting or is forecasting. Okay? And then finally, we see in the system we have a way of feeding back, the truth versus what was predicted, so we can learn from that. So we have a continuously learning system. So now we can move to a knowledge-driven agentic AI that would empower more powerful autonomous operations. And the one nice thing about this, we're talking about a layer on top. So a lot of the engines beneath there can take advantage of knowledge with little change. Change the source of data. Instead of sources of data, you provide sources of knowledge to them. But some of those can remain in place. So you can build it as an overlay, which means you can take it into greenfield sites, of course, but you can also take it into brownfield sites and improve their reasoning capabilities. And we do this with our customers. So many of our customers are AIOps customers. All of them have large, complex network environments, legacy environments, plus 5G environments, okay? And we work with them with a process we call incremental transformation. We say, okay, let's not knowledgeify the world. Let's take a particular business, take a particular problem, okay? Let's define the minimum knowledge required to solve that problem. Let's scope a project that's 60 to 90 days, that has a real ROI, and then let's sprint to get that done. And then when you get that done, choose another one. If it's the same area, then it probably has complementary knowledge that can may even be able to, once you solve that, can help solve the first problem too, or even improve the first problem. And so through these incremental sprints, okay, each is a step, but the journey itself is transformational. Okay. So what we would invite you to do is get started today. Okay, so if you want to, please visit our booth. We're actually right outside the door. Come talk to us a little bit about AI plus knowledge and how to empower agents with knowledge.